Well, I'd like to welcome you today to our Beef and Forage focused webinars. Again, this is a series of webinars that we hold on the first and third Tuesdays of the month. And pleased today to have Rick Rasby with us, who's a beef specialist at the University of Nebraska-Lincoln. He's going to talk about carrying and feeding cattle during winter weather.
Thanks, Aaron. It's a pleasure to be on this morning or this afternoon, whatever time zone you might be in. But we're going to talk about carrying and feeding cattle in cold weather conditions. And I think as you think about how you might go about helping producers, or if you are a producer, how you might think through this. We lost some slides, Betty.
No, they are up here.
Where are they?
I'm seeing them just fine.
Okay, well, the next slide's not right, but it's okay.
This is not the right slide?
Yeah, this is not the right slide, but this is, there's, okay, that's okay. We'll just continue to go on. But the thing that I'd have you think about from a producer standpoint is that trying to adjust sometimes to feed cows when it's extremely cold can be a little bit difficult. The one thing about temperature change in Nebraska is that sometimes we may have extremely cold weather for maybe 3 to 4 days or maybe up to a week, and then how much you might want to think about changing your diet or ration that you're taking out to cows. You need to think through that, how you might do that. The other thing is that sometimes when you get into some situations, it may be so daggone cold that you can't get enough energy out there to the cows. And in those situations, the idea is that you probably just want to get feed out to the cows so that they have something to eat. And so just think through that, how you might adjust rations in those scenarios. The other thing that I would say is that body condition score and body condition of cows is kind of your insurance or your risk management strategy. And understand that cows that are in better body condition are able to withstand some of those lower temperatures, some of those really those climatic conditions that are really tough on livestock. And so if cows are thinner, they have less ability to basically withstand some long periods of cold temperature, and then cows that are in average or fleshy condition are in much better situation to be able to withstand those conditions. So this is a table, a lower critical temperature for beef cows with varying coats and coat condition and body condition score. And so what you see here, you see the type of coat here along the left-hand side of the table, heavy, which would be heavy winter coat, a winter coat that may be just less heavy, or maybe as you approach from fall into winter, and then you have a fall coat, and then you have a summer coat. And so that would be the coat density along that side, the left-hand side of that table. Then you have conditions of that coat either being dry, muddy, or wet. Then you have cow body condition, and so cows that are thin versus cows that are average body condition, and cows that are fleshy when their coat condition is dry. And then the same kind of thing, average, thin, average, and fleshy when the coat is either wet or muddy. But take a look at what happens to lower critical temperature. When you have cows in thin body condition, even though they're dry, heavy winter hair coat, fall hair coat, and then summer hair coat, you see how the lower critical temperature goes up. Same kind of thing holds true for average, and same kind of thing holds true when the coat is dry and the cows are fleshy. But you take a look at it as you compare across here, cows that are thin with a heavy coat, a lower critical temperature is 27 degrees Fahrenheit, or at least 27 degrees lower critical temperature. Dry coats, average temperature, or the lower critical temperature would be 19, and then fleshy, the lower critical temperature would be 11. So as you move this way across the table, it goes down because of body condition. Same kind of thing holds true, even though lower critical temperature is greater or higher when the hair coat is wet or muddy. But the same kind of thing holds true as you move from thin to average to fleshy cows when you look at body conditions. So these will be some numbers that we're going to come back and visit just a little bit later on. But that's how the table's put together. Hair coat along the left-hand part of this axis, and then coat description along the top, and then cows are either in thin, average, or fleshy body condition. If I'd put a body condition score on these would be cows that are probably 4 or less. These are cows that probably average body condition would be 5s and 6s, and then this would be probably 7, 8s, and 9s. That's how I would probably use the 1 to 9 scoring system in this particular scenario. So the other component to trying to decide how much more energy that you need to take out to those cows is in this wind chill index, and I think we all understand wind chill index. And in this particular table, you have temperature in Fahrenheit along the top axis, so we go from minus 10 degrees Fahrenheit all the way up to 40 degrees Fahrenheit, and then part of the equation for wind chill index would be wind speed, and this would be in miles per hour. This would be calm. This would be 10, 15, 20, 30, and 40 miles an hour in regards to wind speed. And so when you put wind speed and temperature together, then you arrive at wind chill, right? So calm, 0, wind chill would be 0. Then you say 0 degrees Fahrenheit with a 10-mile-an-hour wind, you're at minus 11. And so these kinds of numbers are going to be used in developing how you might change the energy density of the diet due to cold winter temperatures or due to the cold temperatures. So this is how you would calculate. So cold stress, the equation is cold stress equals lower critical temperature, which we get off of that first table that we talked about, minus wind chill index, okay? And then for in regards to energy adjustment, for every percent increase in magnitude of cold stress, there's a percentage unit increase in energy adjustment. And so this is how how you would use those tables to arrive at what at cold stress. And so here we have a dry, heavy winter hair coat. Lower critical temperature would be 19 degrees Fahrenheit. And so if we would go back to that previous table, this is where this would be dry, average body condition, heavy winter hair coat, lower critical temperature being 19. So let me move back again. I said 10 degrees Fahrenheit wind speed at 10 miles per hour. Wind chill index then would be minus 1. And so if we'd go back to the table 10, 10, let me see. So I've got 10 degrees, 10 degrees Fahrenheit, 10 mile an hour. This would be minus 1. That's where I got the minus 1 off the table. And so magnitude of coldness would be lower critical temperature minus wind chill index. So magnitude of coldness would be 19 minus a minus 1 equal 20. Now, does that make sense to you? 19 minus a minus would be plus, right? That would be fifth grade math, if you will. So 19 minus a minus 1 or 19 plus 1 would be 20. So when you get to the adjustment for energy, one percentage unit for each degree magnitude of coldness equals 20. So if the TDN requirement is, let's say, is 12.2 pounds per head per day, 12.2 pounds times 1.2, right? That would be an increase in 20%. You'd want to be able to feed those cows 14.6 pounds per head per day of TDN, given the conditions that we described up here. And so if a hay is 56% TDN, then 14.6, I get 14.6 because I needed to change that 12.2 pounds of TDN requirement due to the degree of coldness. Change that to 14.6. 14.6 divided by 0.56 means that that hay is 56% TDN. Then we need to feed 26.1 pounds of TDN, or 26.1 pounds of this hay that's 56% TDN to get 14.6 pounds of TDN into that animal. And so that's on a dry matter basis. And so the next thing you'd have to think about is that if this is a 1,200-pound cow, can I actually get 26.1 pounds of dry matter into that cow? So if I would make a real quick calculation to see what kind of intake that is, if I would take 26.1 and then divide that by a 1,200-pound cow, that means she needs to eat about 2.2% of her body weight to get that extra energy into her. And so she can probably, in fact, she'll eat that that extra 2.2% of her body weight to get that extra TDN into her system. So the idea here is that cold stress is wind chill index minus lower critical temperature minus wind chill index, and then you basically get these numbers. It's 19 comes off of that first table that we talked about. Then you go to the wind chill index table, 10 degrees Fahrenheit wind speed at 10 miles an hour. So the wind chill index is -1, and then you just go through the math. And then for each magnitude of coldness, you increase energy needs by about 1%. And then I went through the calculations here with you. So I just thought maybe we might take just a little bit of time and review body condition scoring, because I think it's one of those things that as you think about how you might manage cows in cold temperatures, I think the previous equation that we just went through, that if we see in the forecast that we're going to have a large, let's say maybe a couple weeks of really tough weather for cows, we need to probably adjust the diets that we're taking out to those females. The other thing that I said early on in the presentation is that body condition of those cows is one way to help manage through at least short periods of real inclement weather. And so if we use the 1 to 9 scale, the cow that I have in front of you right now, this would be the rear view of that cow, and then a side view of that cow, is that this cow would be what I consider body condition score 3. And you think about her ability to get through some really inclement weather, such as low temperatures, and then maybe even temperatures then are influenced by wind chill index. She just doesn't have a lot of cover, if you will, to help her get through some of those really inclement kinds of situations. You move up to a cow that's a body condition score 4. She's just in a little bit better body condition, but still, I would classify her as thin in the tables that we looked at, and then her ability to withstand some of those real extreme cold conditions, because her lower critical temperature is higher than cows that are in a little bit better body condition. She's just going to be challenged in some of these cold, wet conditions that we can experience here in Nebraska. This is a cow in body condition score 5, and you think about how we manage maybe some March calving cows. You know, this is the body condition, I think an ideal body condition that we need to have our cow herd in. These cows are going to be able to withstand some inclement weather much better than the previous 2 cows that I showed you here that were in body condition score of 3 and 4. And then you move to a cow that's just a little bit better body condition. This would be a cow that's in a body condition score of 6. Again, she just has more cover. You take a look at the fat. There's a little bit of fat in the brisket, then you don't see into the ribs, and a little bit of fat over top the tail head. And again, these cows are again going to be able to withstand some of those real inclement conditions much better than the previous 3 cows that I showed you. The cows in the condition score 3, 4, and 5. But from a herd management standpoint, I think for March calving cows, if we basically target those cows to be in a body condition score of 5, I think for Nebraska conditions, we're going to be able to manage those cows through some pretty inclement kind of conditions. Again, like I said, typically in Nebraska we'll get maybe 3 to 5 days of real tough weather, and then after that it usually kind of straightens out. But if we get into long periods of cold weather, cows in body condition score 5, we have to adjust that diet that we're taking out to them. And the idea here is that they probably just need more energy, and they do need more energy based on the calculations that I showed you here a little bit earlier to get through those long periods of really cold and inclement weather. The other thing that I would maybe have you think about is that shelter really is one of those things that becomes pretty important to have developed on your operations to help protect cows during some of this inclement weather. shelters, if constructed right, and basically maybe take the wind out of the equation, that cows can maybe get in behind of shelters if that wind is out of the west or northwest, which is typically where we get it during the winter time. It will help reduce the energy needs in inclement weather, especially on cold days. Because remember, part of that equation, when we figure out the energy increase, our energy increase that we need in inclement weather, if we keep the wind off of them, that has a really dramatic impact on energy needs. So, how you develop those windbreaks, I think, become pretty important. Trees can be in shelter belts are good windbreaks. They work well. Need to be designed so if we do get inclement weather, cattle don't bunch, and then it would be important that we have plenty of shelter belt, especially during a calving, so that they don't bunch and maybe trample on the calves. And so these work real well. You take a look at a lot of the more established ranches out there. They've developed some kind of windbreak shelter with trees that really helps them get through some of this inclement weather that we talked about here early on. There's other ways to develop shelter belts. If you take a look at the Midwest Planning Magazine or catalog, there's shelter belt designs that are man-made. Some of those can be composed by putting some bales together. I don't know if we have enough bales this year to use in that because we're already short on forage, but there are some constructions where they've used canvases and then some tin where they've developed shelter belts when they put them on these fairly large, let's say, telephone poles that maybe have been cut in half or some railroad ties. But shelter belts can be designed and can be used very effectively in these kinds of conditions where we have cattle that are experiencing some cold stress, and just getting them out of the wind helps reduce the energy needs in these particular situations. I would make one final comment is that don't forget the bulls. And we talked a lot about cows, but that bull battery that you have out there is pretty important as well. And so having them in proper body condition going into the winter can sure enough help them withstand some of these inclement conditions. So don't forget the bulls. In extreme conditions, if they're not in the right condition or maybe protected by some kind of shelter belt, they can lose weight, they can lose body condition. And the thing that I would say that you get some of these conditions where we have really low temperatures along with some wind, and you can very easily get testicular damage on bulls if they're not in some kind of protection. And so we've seen it in some of these environmental conditions where we've had some damage to the testicles, frostbite, and that does have a negative impact on reproductive performance of these bulls. And so my point here is that we talked about cows earlier, but don't forget the bulls and being able to maybe increase the diet for them when you get into some of these really extreme cold conditions over a long period of time. And the other thing is that it would be really important for them to be able to get out of some of these extreme conditions because of the possibility of having some frostbite and having a negative impact on future fertility. So make sure you feed them or make adjustments much like you would with the cow herd, and then provide them with some kind of protection, especially when you get into some of these real low wind chill index. The other thing I would say is that from a bedding standpoint, we don't really talk a lot about bedding on cows, but it may be more important in regards to bedding for bulls, especially when you get into some cold conditions and you get into maybe some muddy, damp conditions where the bulls, they lay down. Having some bedding in that particular situation can probably help alleviate or at least minimize the possibility of any damage or frostbite to the testicles. So that's all I have for today. Again, I think as you think through how you might manage cows in cold environmental conditions, body condition is important and can help basically get cows through extreme cold conditions. and it's kind of your insurance policy to a certain extent. Thin cows won't be able to withstand some of these conditions as well, and they won't be able to withstand these conditions as well as cows that are in moderate to fleshy body condition. And then the other thing would be is to have some protection. Again, you may get into conditions where you go through that calculation where you cannot really, as a full feed of corn, you can't get enough energy into those animals to get through those really extreme kinds of conditions. And so really in those conditions, you want to think about, can I just get feed out there for them to eat? Because a lot of times when you get into these really extreme cold conditions, the cows probably aren't worried about eating for the first couple of days. They're probably just worried about trying to stay warm and get out of the get out of some of that, maybe some of that environment, being able to get behind some kind of shelter belt or something like that. But if you get to periods of time where we might go a week to 2 weeks in some of these conditions, it would be important to change the diet, increase the energy density of that diet, so that cows, especially March calving cows, don't lose weight and body condition prior to calving. With that, Aaron, I don't see any questions. I'd be willing to entertain any questions right now.
If you do have any questions, you can type those in the chat box down below, and then Rick will be able to answer those for you. I don't see any questions, Rick. I appreciate your time today. I would remind you that coming up on February the 5th will be our next Beef and Forage Focus webinar. We're going to talk about annual cow costs and how that relates to unit cost of production. With the costs we're seeing right now for harvested feed in Nebraska, annual cow cost and how that affects unit cost of production is going to be pretty challenging as we look at 2013. So that'll be coming up on February the 5th. Thanks, Rick.
All right. Thanks, Aaron.